Today I'm building the timer plus relay circuit from Timer Op Amp and Optoelectronic Circuits and Projects by Forrest and Mims the third. And just want to show that this is how I do it, gathering all the parts, looking at the circuit here. This right here is the 555 timer. This is the switch, two diodes, and the resistor, capacitors, another resistor. I didn't have the exact diodes he's asking for. These are, what are these? 1N401. So hopefully that works. And this is a relay I had. All right, let's put it together. Okay, that took a lot longer than I was hoping, and I ran into a few problems. Well, first of all, the relays I had weren't right for this circuit. Like, this is an AC relay, so this is a DC circuit, and this is a 48 volt relay. I think it only works with 48 volts. I couldn't get it to trigger, but I remembered that I had this thing called a tip 120, which is used for motors and stuff in Arduino. You'll never be able to see that, but it says tip 120 on top of there. And so I ended up using that instead of a relay. It still gets higher voltage, and that's coming in here. And it's currently wired up to drive this solenoid. It's also driving this LED. So I'll just give a quick demo. So the duration that it's on is determined by this capacitor and also this resistor, I believe. Actually, in the diagram, I realized after the fact that this is a potentiometer as well. I didn't have a 1 M. Closest thing I had was 500K. And by the way, you can measure your potentiometer with a multimeter by setting it up to read resistance and hooking it up to the two outside leads, and then like just measuring it, and it'll tell you how much it is, like regardless of where it is on the knob. But for now, I'm just using this. I only have it on, this is a pretty big one. It's 100 microfarads. So if I swap it out with, I think this is 10 microfarads, the duration will be a lot shorter. Oh, shoot. And I wanted to show also hooking it up to something else. So I have this right here. This is a doorbell. And there was normally a bell mounted here. Let's see if I have it handy. Yeah. But I was trying to see if I can get it to be like with a mallet, but it's not really working the way I wanted, but I'll show you that as well. So I'm just plugging that in. It's going to get the same. Actually, I'm going to change the voltage down from 12, which that motor was using, down to something much smaller, 5. I have a power supply thing over there. Okay. So now when I press the button, let me zoom out again. When I press the button, this thing is being, the current is going and activating this. So I should probably mention this is what the heck this is. There was not enough room on the breadboard, but I also like the idea of it being slightly modular, like I could disconnect this whole piece and it would still function with this LED. And so what's going on here is the tip 120 circuit. The higher voltage is coming from here. It's using the same ground. You could see this is connected here to here, which is connected to the common ground in the low voltage circuit. And there's a resistor going into the tip 120. Here's actually my notes. So the left one is the base, collector, and emitter. Sorry, it's not in perfect focus. And this is the circuit I found online somewhere. Not sure where. I'll try to link that in the description. But anyway, there's a 1K ohm resistor going into the middle part. The 1K ohm is going into the base, and the it's hard to explain. But if you look at the circuit, you can see how it's working. The high voltage is coming in to the motor. There's a diode between the positive and negative. What the heck was that? Sorry. It was just the wind. Okay. Well, I think that's about what there is this show. Thanks for watching, and hope this was helpful. See you in the next video. Bye.